Okay, for this first part of this section, I'm going to go ahead and program this system using ladder logic. So if you remember your ladder diagrams, if you know how to create ladder logic, and it's just the simplest thing in the world, if you've been working with it, you already know this stuff, please feel free to skip over this section of ladder diagrams because it's going to be very old and very redundant for you. For anybody who hasn't taken PLC 1 or PLC 2 for a while, hasn't worked with this stuff and needs a refresher, this part's for you, so stick around and hopefully it'll jog your memory and, kind of get you back on track with this stuff. So I'm going to create a new project. The controller for this is going to be my emulate controller. And for a name, I'm just going to call this Tank 1. That sounds good, right? And we're going to put that on, really it doesn't matter what chassis it's on because I'm not actually going to use any I/O, so I'm just going to leave it there. I'm going to put my controller in slot 2 because that's how I have emulate set up. And then I don't want my project to be hidden off somewhere in space. I want it to be on my desktop. So let's go ahead and, whoops, I've got to put in a controller version for emulate. Let's go ahead and make it 20. Gotcha. Okay, so we've got our program created. I'm going to come in here to the main program, main routine, and just for simplicity's sake, I'm not going to use my usual program architecture. When I'm laying out a program, I usually like to fill this thing up with multiple ladders, have everything nicely segregated, but in this case, this is a very simple system. I want to give you a very simple example, so I'm going to do this all in one place. So the first thing I know is because I have such a simple system, I can just break this thing down into certain stages of what that thing's going to be doing at any given time. I want my system to either be off or on. If my system is on, I want it to be in one of a couple of stages. I either want it to be in fill, I want it to be in drain, or, theoretically it could be in low-low or it could be in high-high. So between those 4 operating states and my disable or off state, I have 5 different states that this machine could be in. So I'm going to go ahead and create logic that's going to set up those states and manage them with an integer. So let's start by creating a move by clicking MOV up top under my move box. And move source, I'm going to move the source 0. And I'm going to move it into the destination of state _ int. Now, as soon as I enter that, you see I get these E's over here on the left. That's telling me I've got an error. My error is that I've got this destination and the tag is undefined. So let me define that tag. I'm going to right click and create a new state int. That's going to be dint, which is my integer. That's exactly what I want. And I'm going to go ahead and leave the scope of this in my program. I don't think I need to put that up onto the controller scope. So let's just leave it right there. Hit create. And as soon as I do, all those E's I had over here on the left disappear. So now I've got a block which is moving 0 into the location of state int. And I've got that set up. I'm going to have 0 be off. And let me copy this rung and create 4 more because I also want to be able to move 1, 2, and 3, and 4 into that place as well. So now I've got conditions for off. I've got a condition for fill, drain, low alarm, and high alarm. But I'm going to go ahead and create one more of these actually because I want an intermediary step whenever I first enable the system. Before I've determined exactly what my level is, it's going to be kind of in a standby mode. So let's just go ahead and create one more place for that. So now, how am I going to get into these different modes? Well, to get into my 0 mode, which is off, I want to have to hit a stop button. So I'm going to come back over here to my bit tab, and I'm going to create an XIC, and that's going to be associated with a tag called stop_btn. And as soon as I create that, I can right click, create a new stop button. You see my data type is a bool. That's exactly what I want, because this is a digital signal. It's either on or off, 0 or 1. We know that by now. And I'm going to leave my scope as the main program and create that. Then I'm also going to want a one-shot in here, because whenever I push that button, while I'm holding that button down, I don't want it to be moving a 0 over and over and over again 1,000 times for all these different scans. So anytime I'm using a push button, I'm also going to throw in a one-shot, because that's going to convert a momentary signal, which could last for 100 scans. It's going to convert that into a single pulse, and it's only going to happen for one scan while my PLC is running, and that's what I want. So I'm just going to call this ONS1 and right click and create a new ONS1. It's a bool and it's in my main program. So now I have a way to put my system into stop mode. Well, to get myself into mode 1 is going to be my intermediary mode. That means we just came online, but we haven't yet determined what the level in the tank is. That's going to be triggered by my start button. So same thing, start_btn. We'll right click that, create a new bool in our main program, and then create another one shot, this time ONS2. And we'll go ahead and create a new one of those also. So now we've got a way to turn our system on and turn our system off. Now let's start thinking about how we're going to determine our level. So this rung 2, that's going to put us into fill mode. So how do we calculate, how do we determine whether we need to fill our tank or not? Well, we know we're going to be looking at the low level switch, but we don't want that to be instantaneous, because sometimes water inside of a tank can be turbulent, it's sloshing around, and when you have a digital level switch, that switch can be rocking back and forth, open, closed, and we don't want that to determine our mode. We want that switch to not just close or open in this case. We want to make sure it stays that way for at least a good 5 seconds before we actually take any action. So let's come down here and create some logic. We need a 5-second delay on that, and let's go ahead and create that down here on a new rung. So the first thing we want to do is look to see if our low-level switch is open. So we're going to use an XIO for that, examine if open. And we're going to look at L_SW, and that will be our low switch. And we're going to associate that directly with a timer. So let's come over here to our next tab and take a TON, and I will call this L_delay. And before we can set the preset, if we try right now, it won't let us because this timer is undefined. So we need to create a new LDelay, and it automatically knows that that's supposed to be a timer data type. It's going to put that in the main program because that's what we've been using for scope all along. So now that we've created that, we can come down here to preset, and the presets in Logix 5000 are always milliseconds. So I'm going to put 5,000 milliseconds in there, and that's going to be a 5-second delay timer. So now, once this switch opens, this timer is going to start counting. But I don't want that timer to start counting if we're not actually in the right mode. If we're in an alarm state, I don't want this to even move because I don't want there to be any possibility that we're going to go into a fill mode because it thinks our tank is low. what I want to do is I want this thing to only work if we're in certain modes. So I'm going to come up here to my compare menu, and I'm going to select an NEQ, which is not equal to. I want to reference my state. So then I want to compare that. If it's in mode 0, that means our system's off. Well, I obviously don't want to try to fill the tank if the system's off. So what else do I want to look at? I'm going to copy this and make 2 more. And I know right now that if I'm in state 4 or state 5, I'm in an alarm condition. And I don't want to go into fill mode if I'm actually in an alarm condition. So I want this to not be equal to 4 or not be equal to 5. So as long as we're not in a state 0, 4, or 5, let's go ahead and energize this timer. And once this timer starts, eventually that's going to time out. And when that times out, then and only then do I want us to go into our fill mode. So I'll come up here and I'm going to put one more XIC. So let's go back to the bit tab, put in our XIC, and that's going to be L_delay.dn. So when that timer is done, then we're going to one-shot one more time. So I'll give ourselves an ONS3, and then let's go ahead and create the data tag for that. So now we have a way to get into our fill mode as well. And one other thing I can do up here, I'm going to come up here, right click on this, and I'm going to edit the rung comment. So by doing this, I can actually create a comment up here which is going to tell us what this rung is doing. And this is going to be stop mode. That's good enough. That tells us what's happening. And I can do the same thing for rung 1. So I'll go ahead and edit one more rung comment here. That's going to be start mode. That's going to be our intermediary mode, if you recall. And then down here I've also got a fill mode. So I'll just type that out. And now we've actually got a little bit of a guide step by step in here that tells us what's happening on these rungs. So before this lecture gets too long, let's go ahead and break off here, and I will pick back up right where I left off in the next one. So see you then.